Hi everybody, in this video we are going to talk about reference angles. And I know what you're thinking, great, what's a reference angle? Well, here it is. A reference angle for any angle in standard position, angle theta, is called theta prime, and is the acute angle made by the terminal side of your angle theta and the x-axis. So your reference angle will always be an angle between 0 and 90 degrees, and it will always be positive. Okay, and it is always found with respect to the x-axis. So in quadrant 2, it is going to be this angle right here. In quadrant 3, it will be this angle right here. And as you guess, you have 4 cases. We already discussed 2 of them. First one is quadrant 1, where basically the reference angle is the same thing as the angle itself. In quadrant 2, this is the angle. Okay, this is theta. This right here is the reference angle. And you can find it by basically computing 180 degrees minus theta, and that will give us your reference angle. Now, I don't want you to memorize this. I want you to understand this picture and be able to deduce what this value might be. Similarly, in quadrant 3, here is our angle. Here's the terminal side in quadrant 3, and this is a reference angle. And this is going to be equal to the angle itself minus 180 degrees. Once again, don't memorize this. Just understand this picture and be able to deduce that. And finally, in quadrant 4, this will be your angle right here. And if that's the case, then your reference angle will also be equal to 360 degrees minus theta. Now, in this particular case, you also might find theta being written as a negative values. For example, theta could be equal to, say, negative 60 degrees. In other words, they will give you this for theta, which will be a negative measure. Okay, if that's the case, then your reference angle is just nothing more than the negative of that. So in this case, the reference angle will be equal to 60 degrees. So how do we go about finding your reference angles? Well, to find your reference angle, what you need to do is find the quadrant. We need to find the quadrant in which the angle lies. Now, to do that, you need to find the coterminal angle between negative 360 and 360. It could be between 0 and 360, but for the cases where you might have a negative angle, we can also include the negative 360s. Now, the way that we can do that is using our calculator. What we can do is take our angle, which in this case is 3043, divide that by 360. And your coterminal angle is in the decimal part of this, so what we can do is subtract 8 from it, and then multiply that by 360. And that right there is your coterminal angle. Our coterminal angle happens to be 163 degrees. Now that we know that, we can determine what quadrant it lies in, and we can just basically draw a picture to figure that out, or if you can't already see it. So here's 0, here's 90, here's 180, so 163 is probably like around here somewhere. And once you've done that, this right here is your reference angle, and you know what now you know what you need to do to figure that out. That is going to be 180 minus 163. Okay, so we are in quadrant 2. I guess I should write that down, and that will give us 17 degrees. That is our reference angle. So our biggest thing is we want to find the quadrant. The way you can do that is, 1, find the coterminal angle between negative 360 or 360. Figure out which quadrant it lies in once you've done that, and then you can actually go ahead and find the angle. Now in this particular example, we already have a coterminal angle, or this is already between 0 and 360. Okay, we know that this lies in quadrant 3, and we can easily deduce that this is the angle, and it's going to be 225 minus 180. So our reference angle is 45 degrees. Now, it turns out that if that's the case, then our 6 trig functions are going to have the same value as 45 degrees. The only difference will be the sign. 4 of the trig functions will have a negative sign. 2 of the trig functions will have a positive sign. In quadrant 3, those 2 trig functions with a positive sign are going to be tangent and cotangent. You can easily deduce that because remember, x is negative, y is negative in quadrant 3, and r is always positive because it's a distance. The sine of 45 degrees is the square root of 2 over 2. The cosecant of 45 degrees is the square root of 2. The cosine of 45 degrees is the square root of 2 divided by 2. The secant of square root of 3 is of 45 degrees is the square root of 2. The tangent of 45 degrees is 1. Cotangent is also 1. And every single trig function is negative, at least for 225 degrees, with the exception of cotangent and tangent. So these are positive and these are negative. And that is your answer. Once again, sine, cosine, cosecant, and secant of 225 degrees is basically just the negative of the same functions for 45 degrees. And in case of tangent and cotangent, they happen to be the same. And that kind of gives you an idea of how you want to find trig functions for any non-quadrantal angle that has theta. And the first thing is, if theta is above 360 or less than 0, we want to find the coterminal angle between 0 and 360. Actually, it's okay if we go from negative 360 to 360. Okay, once you've done that, you will be able to find the quadrant. And once you've determined the quadrant, you can find the reference angle. Then you can find the 6 trig functions for that reference angle. And then once you've found those functions, just go ahead and, based upon what quadrant it happens to be in, determine which function should be positive and which of the 2 functions should remain positive and which of the other 4 functions should become negative. And that says in quadrant 1, and of course then everything is positive. And that brings us to our very last problem, at least for this video, and that is to find the exact value for cotangent 1020 degrees. Well, we can't do that until we figure out what quadrant that is in. So to find that quadrant, what we need to do is we need to figure out, find the coterminal angle between negative 360 and 360. And we can find that by dividing 1020 by 360. Okay, removing the 2, and then multiplying the decimal by 360. And that gives us 300 degrees. So our coterminal angle is 300 degrees. And as you can see, that is in quadrant 4. And then our reference angle is this angle right here, 360 minus 300. That is 60 degrees. And it turns out that the cotangent, the cotangent of 60 degrees is going to be the square root of 3 divided by 3. Now, since we're in quadrant 4, the only functions that are positive in quadrant 4 are sine and cosecant. So the cotangent of 1020 is going to be the negative of this, or negative square root of 3 divided by 3. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.